Our lesson for today will be looking at Chemistry 1502. The topic for today is bond fission, lesson 101. Let us start. So far, you know that the atoms, they normally bond through chemical reaction. Now, you should know that there are two different types of chemical reaction. Like I said, so far you're exposed, or you know, according to the knowledge you've gained in Chemistry 1501, that atoms, they chemically bond to form new substances. So in this lesson video, we'll be looking at how they actually break and the terms which are very important. Within this lesson video, we'll be dealing with a few concepts. So we are looking at bond fission. Some say it's bond cleavage, some say it's bond breakage. Now you should know that fission of covalent bonds, breaking of covalent bonds can take place in two ways. So we have two different types of bond fission. The first one is homolysis. Some say it's homolytic, homolysis fission or bond fission. The second one is heterolysis fission, or sometimes we say it's heterolytic or homolytic. So we have these two different types of bond fission. Let us start by explaining the first one, which is homolysis fission. In homolytic bond fission, the breaking of covalent bond between two atoms take place in such a way that each atom takes one of the bonding pair of electrons. Now we know very well that if we have two atoms bonding with each other covalently, it means that they share electrons, and then this one line simply represents two electrons. So when we look at a homolysis bond fission, it's when each and every atom will take one electron. Remember that this hook arrow simply represents a movement of one electron. So both of them, they will have an electron from that bonding pair. And you should take note that it doesn't necessarily mean that the atoms should be identical. We can have different types of atoms, but as long as they both gain electrons from that sigma bond, then we say this type of bond fission is homolytic. Now let us look at a few examples. Suppose we have chlorine atoms bonding with each other. Know that you're going to have lone pairs. Then when they undergo homolysis, the electrons here will be shared equally. When it comes to the colors, it's actually vice versa, but I believe you can see what I'm trying to explain here. And you should also know that it doesn't necessarily mean we only have this type of bond fission on atoms. We can also have this type of fission in compounds. Let's say we have C2H6, which we are going to have something like this. then we can just write it in this manner: H3C bonding with CH3. So we have electrons here. You can see this is a covalent bond. And then when they undergo homolysis, we're going to have something like this. And after these electrons are shared equally, we call the products free radicals. We're going to talk about this later on, but you should know that they yield free radicals. Also these ones, we call them free radicals. Also these ones. Now I hope you understand the homolytic fission. Let us go to the next one, which is heterolytic fission. Okay, when we look at heterolysis or heterolytic bond fission, in heterolytic bond fission, the breaking of covalent bond between two atoms takes place in such a way that both of the bonding pair of electrons are taken up by one of the atoms. So there is no sharing of electrons here. Both of the sigma bond, actually the sigma bond is taken by one atom. Okay, let us look at a general equation. Suppose we have X and Y. They undergo heterolytic or heterolysis bond fission. Remember that we have two electrons here. They will both shift to one atom. Now we should understand something. It doesn't shift to any atom. It fully depends on the electronegativity. Remember that if this one loses electrons, it becomes positively charged. Then this, with an extra electron, it becomes negatively charged. Let us look at this example. Suppose we have hydrogen bonding with chlorine, and then they undergo bond fission, which will definitely be a heterolysis bond fission. Now we know from resonance structures, in order to be able to determine which resonance structure is stable, especially when we have resonance structures which has equal formal charges, we look at electronegativity theory. We know that the negative charge normally would be more stable on an atom which is more electronegative. So in this case, looking at the electronegativity of chlorine compared to hydrogen, we know that chlorine, it is more electronegative compared to hydrogen. So it simply means that the sigma bond, or these two electrons, they will shift to chlorine, and then it will result into hydrogen and chlorine. Our chlorine atom will be negative, our hydrogen will be positive. Another example. Let's say we have H3C bonded with OH. Now you can see carbon and oxygen. Oxygen is definitely the one which is more electronegative, so it means that the sigma bond will come here, leaving CH3. Let me actually write it this way: H3C, going to have a positive here, a negative here. So these are the concepts of bond fission. We are going to talk about the free radicals and ions in the next lesson video. And by the way, if we have the product of heterolytic bond fission, the products, we call them ions. As you can see that they have these charges here. Remember that we said we have free radicals in homolysis, in heterolysis we have ions. That's it for this lesson video. This is Fahula SJ. Thank you very much.